going to go over this paper fall leaf color with you. You should be on a page that looks like this and starts with what it says fall leaf color. The part that talks about why leaves are green and the part that says about how leaves turn brown in the fall and why does it happen, you should have already done that part all on your own. Down below, it talks about the above is a hypothesis, and it asks what a hypothesis is. We're going to give perhaps a new definition of hypothesis. We want to use the term testable explanation when we talk about a hypothesis. Oftentimes, a hypothesis is referred to as an educated guess. And that is a term I don't want you to use. A hypothesis is not an educated guess all the time. Some educated guesses are testable explanations, and some of them are not. All testable explanations are hypotheses, though. That's the key. So in order for something to be a hypothesis, it has to explain something in a way that is testable. Down below, it asks us, why do scientists use hypotheses? And I'll kind of scroll into that a little bit and change the color just so it's easier to follow along with me. Why do scientists use hypotheses? And this is just to get the scientific process started. So in order to get the process started, get things moving, we make a hypothesis. It's explaining something in a testable manner, so it kind of lets us have something to finally test. So this next part says after testing, if a hypothesis is not proven false, it may become a law, a theory, a fact, or still remains a hypothesis. The correct answer here is actually D, that it still remains a hypothesis. But before I explain why, we're going to quickly go over what a law, theory, and a fact are. A law is an observation that's true, simply that. Gravity is a law. It is something that we always see happen. When something falls, the object goes down towards the Earth, or in a larger sense in the universe, what happens there. A theory is going to change colors for us again. A theory is another explanation that using several hypotheses. So it brings together several hypotheses, which if we remember are testable explanations. So if we have several testable explanations all brought together, then it's um, a theory. A scientific fact is slightly different from any of these again. It is simply a true observation. It differs from a law in that a law is something that's observation that's always true in a really general sense. A fact is just something quick and true that happened. And then again, a hypothesis is what we've said before as a testable explanation. All right. This next part of the activity we've already went over, so we're going to cruise right past that and see if it goes a little faster here. Maybe I can go We went through this stuff with the colored leaf already, and actually we're going to talk a little bit about microscope use and slide viewing. The actual microscope use itself, I'll show you how to do, but I wanted us to get an idea about how microscopes are set up and how they work. A microscope, I'll just kind of read through this, is a complicated piece of equipment. It does use two sets of lenses that bend light to enlarge an image. In order for it to work, light's projected from the bottom of the microscope, and it shines through whatever we want to observe. So that means something has to be pretty thin for us to see it in a microscope. A lens is placed over that enlarges it two different ways. The first enlargement happens through what is called the objective lens. On our microscope, these have numbers on them, and if you were to look at a microscope, and there should be one sitting next to the computer here, there's simply three different numbers on them. One has a 4, one has a 10, and one has a 40. So you should write that in those blanks. A 4, a 10, and a 40. Feel free to pause this video and take a look at yourself on that microscope to see that 4, the 10, and the 40. Now this enlargement is enlarged again to the top of the microscope, which you look through. That is called the eyepiece. The eyepiece is enlarges an already enlarged image. So we took an image and enlarged it 4 times. And we're going to enlarge that 4 times image even more. And we're going to enlarge it another 10 times. So to get the idea of the size of the image, we just simply multiply either the 4, the 10, or the 40 times 10, and it gives us our overall magnification. The shortest lens is red, and you should see that red on it. There's a 4 written on it, so the magnification of that, if we're looking at something through it, is 40. I don't really care if you realize that it's 40 or 40x, meaning 40 times bigger, but I do want you to realize that that is low power. The next one is yellow. Let's see how well we can see this. Medium power is yellow, and has a 10 on it. Okay, so we're going to take this 10 and multiply it times 10. So we're going to get a 100x magnification, and that's going to be referred to as medium power. And lastly, we have one that is blue, and it has a 40 written on it. So that magnification is going to take 40 times 40, or 400x. So whatever we look at under high power, we're seeing it 400 times bigger than what it really is. And again, that's high power microscope. All right, the rest of it, after you've went through all of this, got all of these things written down that I've written on here, then you can come to me and I'll show you how to actually use the microscope itself.